This is just a short little video to show you how to make a graph in Google Sheets. I have some data here. I'm calling this free fall, so I have collected 6 trials per situation. So each height is its own situation, and I have found these 6 trials. The first thing we want to do is we want to find the average of all these times. So I'm going to hit the equal sign. That tells the computer I'm getting ready to put a program in. I'm just going to type in the word average, and then in parentheses I'm going to highlight the numbers I want to find the average of. Then there's this little box in the bottom right corner. I can click and drag that down, and that finds the average for each one of those rows. Now I'd like to find make a plot of this. And remember, when you make a plot, you want to have your x column before your y column. So I want the times on the x, the height on the y. So I'm going to highlight my data. I'm going to go up to Insert, and I'm going to insert a chart. I'm going to choose Scatter Plot. And then for customizing it, I'm going to change this to my experimental data. On the horizontal axis, this is the average time, measured in seconds. And then for the vertical, will be the height, measured in meters. I now want to add a trend line. Now notice if I do a linear trend line, it doesn't quite fit the data. So I'm going to change this to a polynomial. That looks a lot better. If I click on the show r squared value, I get a 0.999, which is good. The closer you get to 1, the better. And for the equation, where it says label, I'm going to click use equation. That'll make my chart right here for my experimental data. The next thing I'd like to do is I'd like to compare that against maybe a predicted height, or predicted times. Well, when something falls, remember that the time it takes to fall is the square root of twice the distance over the acceleration due to gravity. So I'm going to put in a formula, so I'm going to hit the equal sign. In parentheses, I'm going to have twice 2 times the height. Then I'm going to divide that by the acceleration due to gravity, 9.81. Now all of that, I need to take the square root of that. So in front of that, I'm going to take the square root, so SQRT. That finds the square root of twice the height divided by the acceleration due to gravity. And go all the way to the end. So that's the predicted time, and I can take this and scroll down, or populate the list down, and that gives me times for each one of these heights. Now I'm going to highlight this data, and I'm going to insert a chart. Again, I'm going to make a scatter plot. Under customizing, this will be my predicted data. Predicted time for my x-axis, and height measured in meters for my y-axis. Under trend line, once again, notice that the linear doesn't work out for this, so polynomial, the r squared value is 1. I should get 1 since I'm using the formula, getting predicted values. Use the equation for the label, and we can go ahead and insert. So then, we can go ahead and start comparing these 2 charts. So they look very similar, which is what I would expect. Here in front of the x squared I have 5x squared. Here I have 4.9x squared. So very good data here. Now the next thing I would want to do is I want to find the precision. How precise is my data? To do this, we use something called standard deviation. So I'm going to hit the enter, and then even if I just type in ST, I see that I get my standard deviation. So I'm going to click on that. Now I need to find the standard deviation of some numbers. So I'm going to find the standard deviation of these 6 trials. Close up the parentheses, hit enter, and that gives me my standard deviation. So I can come down through here and populate that list. And for standard deviation, you want it as small as possible. So 0.01, 0.006, these numbers are all very, very precise. The data is very well clustered together. Now for accuracy, remember that it's a percentage, and we take the measured value minus the accepted value divided by the accepted value. Well, in this one we don't have accepted values, but we have predicted values. So to do this one, my formula is going to be something times 100, because I want to turn this into a percentage. So I'm going to have my average value minus my predicted value. All of that will be divided by my predicted value. And when I hit enter, I get my percentage error. So it's negative 0.78% for that first one. So populate this list down. And really for accuracy, as long as you get lower than 10%, that's pretty good. So it looks like my highest one is 5%. Now the negative means that it's below the accepted value. Positive, such as these ones right here, positive means that it's above the predicted value. But there you have it. Notice with this experiment we have multiple situations. For each situation we have multiple trials, and that's where you keep everything the same and you just test it over and over again. We got our average. So we got our plots for our independent versus dependent variables. We have something to compare it against. So we got our predicted values, and we have our precision and accuracy. Hopefully this will help making graphs for future experiments.